Hello and welcome to all of you. I hope you all are doing well. So, in this video, I'll cover the EOT solution, and the whole video will be categorized in two parts, part 1 and part 2. So, let's begin with the part 1. So, first thing which you have to recall, that is the number of lessons which you have to cover. So, actually, there are total 3 modules. The first module, vibration and wave, the first lesson you have already done in term 2, so you don't have to cover in this term. Wave behavior you have to cover, so it means in the first module you have to cover only lesson 2, correct? Then the second module is sound. Here you have to cover 2 lessons, properties and detection of sound and the physics of music. And the resonance in air column, the page they have already given to you according to EOT. So there will be total 2 lessons here you have to cover, correct? So 1 lesson from here, 2 lessons from the second module, and the third module is fundamentals of light. Here you have to cover 2 lessons, illumination and the wave nature of light. So here also there are total 2 lessons. So there is total 1 plus 2 plus 2, 5 lessons you have to cover in this term. So you all know that this term there will be total 25 MCQs questions, no FRQs, and each questions will comprises 4 marks. So total it will be 100 marks in 2 hours time, means 120 minutes time, correct? So let's begin with the very first objective. It is asking like differentiate between transverse, longitudinal and surface waves and give examples. So here when I talk about these 3 waves, these are the types of mechanical waves. So in types of mechanical wave, the first one they are mentioning longitudinal. So one thing always remember, when I say the wave is always like moving in some direction, correct? So first thing is wave direction, which you have to keep in your mind. Wave direction, technically we are calling it as direction of propagation of the wave, or simply you can say wave direction, okay? And the another is particle. Another is what? Particle movement, or you can say particle motion, okay? So if the particle is moving, listen carefully, if the particle is moving parallel to the direction of wave, means these 2 directions are parallel. So if the direction of particle movement and the direction of wave is parallel to each other, then such wave is called longitudinal wave. So here the main word is what? Parallel. Clear? So what are the directions I'm talking about? 2 directions only. One is particle motion and one is wave direction. So if particle is moving parallel to the direction of wave, then it is called longitudinal wave, okay? For example, we can say sound waves, correct? Sound waves is the example of longitudinal waves. Also, when you produce the wave from the spring, that is also example of longitudinal wave. Longitudinal wave is generally called one dimensional wave also, 1D wave. D means dimensional, means one dimension, only one direction. So it is a one directional wave. Now the second is transverse wave. So transverse wave is just opposite of the first one. I explained already that one is the direction of wave, means wave direction. Another is the particle motion. So now the particle motion, if it is perpendicular to the direction of wave, correct? Particle direction. If particle moving up and down, which is just at 90 degree to the wave direction, means perpendicular to the wave direction, then such wave is called transverse wave. So here the main word is perpendicular, correct? So longitudinal means parallel, transverse means perpendicular. So you can see the wave of transverse look like this, up down. So if you take any particle, it means it is going up down like this. So the upper part, you know that it is called crest. All this is what? Crest. And the bottom part, the down part, is called trough, and like that. Correct? So upper one is the crest, C, and the down one is T, which is trough. Correct? What are the examples of transverse wave? All the light waves you can consider. The light waves are the transverse waves. It is having the same perpendicular direction. There are other example, you can make it from water waves are also like transverse waves. Okay, here they have given you the example of a thread. You can see they have taken a thread and they just push it, and then it will get bounced back like this. So it is having a pulse. This is called pulse, P-U-L-S-E, pulse. Here it is what? Pulse. Okay, so it is forming a pulse like this. So it is forming a wave, which is a transverse wave. Okay, and here longitudinal wave, they have given you the example of a spring, as I already explained to you. So a spring, if you push it, it is called compression, and when you release it, it will get expand. So this is called rarefaction. Okay, so in transverse wave there is a concept of crest and trough, and in longitudinal wave there is a concept of compression and rarefaction. Now the third is surface wave. So surface wave is a combination of transverse and longitudinal. When these two waves are getting combined, it is formed surface wave. So water waves, which I say transverse part of a transverse wave, it is actually a surface wave. So I'll remove water wave from here and I'll put it in the category of surface wave. It is also a transverse nature, but it is along with longitudinal. So you can see that when the water is having a wave like this, it is having a circular part. Correct? So if you see each one of the movement, it is having the particle when it becomes perpendicular as well as it becomes parallel. Okay, so parallel, perpendicular, both are coming. That's why we will say at surface wave. So when we say the example of surface wave, we can say water waves. Okay, so water waves I'll remove from here. So generally, when you take some examples of transverse waves, are the ripples on the surface of water, vibration on a guitar string, electromagnetic waves such as light, and some examples of longitudinal waves are sound waves, ultrasound waves. I have already given you examples. So these are the differences categorized for transverse, longitudinal, and surface. So you can pause the screen or you can take the screenshot and you have to memorize all these differences. So first difference is definition, then particle motion, direction of vibration, main parts, medium required, and these are the examples. Is it clear? So you should go through it. Okay, so now let's come to the point of problems. So problems will be based on some formula. So here in the second objective, it is asking you calculate the frequency of a wave from its period and vice versa, means frequency, and apply the relation V is equals to lambda f to calculate the speed, wavelength, or frequency of the wave. So basically they are trying to compare speed, wavelength, and frequency. Okay, so for that, basically you have to remember one formula with the triangle rule, simple rule. Okay, so what is the triangle rule? Here is the velocity, here is the lambda, here is the f. It means that when you have to write the formula of V, you just multiply lambda f. This is the formula. Correct? In terms of lambda, if you hold lambda, here it will be V over f. V over f, divide. Correct? If we have to write the formula of f, if we have to write the formula of f, for example, hold f, then it will be V divided by lambda. Correct? So this is the formula which relating velocity, wavelength, and frequency. What is the relation of frequency with time period? Frequency is the reciprocal of time period, means it is the inverse of time period. T is the time. So when you take the inverse 1 over t, it will give you frequency. So what is the unit of frequency? Unit of frequency is hertz, okay, or you can say second inverse, because the time is in second. So when you will take 1 over second, the second will go up and you will call it at second inverse. So there is a 2 units of frequency, that is hertz or second inverse. Is it clear? So now let's visualize it. So as I told you, like this is a case of the transverse wave, and here this is the portion which is called crest. The maximum displacement along the y-axis is called amplitude. Is called what? Amplitude. You can see that this is the maximum displacement on y-axis. This is y-axis and this is x-axis, correct? So the maximum displacement is called amplitude. Now the distance in between the two crest, the distance in between two crest, or you can say the distance in between two trough, it is called wavelength, lambda. It is called what? Wavelength, lambda. Lambda, this is called lambda, and this is for wavelength, okay? So crest to crest or trough to trough, that distance is called wavelength. Is it clear? So let's have a problem. The first example in your book, it is given a sound wave has a frequency of 192 hertz and travel the length of a football field 91.4 meter in 0.271 second. So first question, it is asking what is the speed of the wave, what is the wavelength of the wave, what is the period, and if the frequency they will change 442 hertz, so what would be the new wavelength and period. So for example, if they are talking about speed, so first thing what you need to do is you have to write the known values, what value they have given to you, correct? So hertz is the unit of frequency, so they have given you frequency. Football field 91.4 meter, this is the distance they have given to you, so this is a normal distance. 0.271 is the time, correct? So what are the relation? We will do that. The basic formula, because the distance they have given to you, so the basic formula of velocity is distance over time, which we have already studied from grade 8 onwards, correct? Velocity is equals to what? Distance over time or displacement over time, correct? So distance they have given to you 91.4 and the time they have given to you 0.271. So when you calculate it, you will get 337 meter per second. Easy. It is already done here. Now the second part is wavelength. Wavelength means lambda, correct? So what is the relation of lambda we have done before? V over F, correct? So velocity you have already calculated, 337, yes? And the frequency they have given to you, 192. When you divide it, you will get 1.76 meter. This is what you got, wavelength, correct? Third thing, it is asking what is the period of the wave. So period of the wave means time period. T is equals to 1 over F. As I told you, like the questions will be in the form of MCQ, so you have to save your time. So 1 over F, frequency is 192. Just take out the calculator, immediately just do it, and you will get 0.00521 second. Correct? And the last question is, if the frequency change 442, what would be the new wavelength? So new wavelength lambda, okay, new. Here it will be the formula which you have to use, V over F. So here you have to use new frequency, correct? Velocity you have already know that, 337. Frequency they change to 442. So when you calculate it, you will get the wavelength 0.762 meter, correct? This one. And then they are asking period. So period means time, new time period, correct? So new time period will be 1 over new frequency. So new frequency is 1 over 442. When you solve it, you will get 0.00226 second. This is the way you have to solve the question. Now the next question. A sound wave produced by a clock chime is heard 515 meter away 1.50 second later. So this 515, this is what? Distance, correct? 1.50 second is the time. Based on these measurements, what is the speed of the sound? So what is the formula of speed? V is equals to d over t, distance over time. So distance is 515, time is 1.50. When you calculate it, you will get 343 meter per second, correct? The second question, they are saying the sound wave has a frequency of 436 hertz. So they have given you frequency. What is the period of the wave? So what is the meaning of period? Means time. So what is the relation? 1 over f, correct? So 1 over 436. You will get 2.29 multiplied 10 power minus 3 second. Easy. Then it is saying what is the wavelength? So what is the relation? Lambda is equals to v over f. So what is the velocity? You have already calculated 343 over f. F you have, they have already given to you 436 hertz, correct? So when you calculate it, you will get 0.787 meter. That will be your answer. These calculations is already given to you. Now here the next question is, how are the wavelength, frequency and speed of the wave related? How do they depend on the medium through which the wave is passing and the type of wave? This is an important aspect as point of MCQ. Okay. So the relation, as I told you, lambda is equals to v over f. So what is the relation of lambda with frequency? It is the inverse relation. Frequency is down, lambda is up. So if the frequency will increase, lambda will decrease, correct? Or if the frequency will decrease, lambda will increase. So this is what the opposite relation they have. Okay. Now if you see here, frequency is always constant in a medium, like constant in a medium change. Like when you are changing the medium, let us suppose when you are changing the medium from air to water. So during this change, okay, frequency will remain the same when wave moves from one medium to another. Okay, this is because frequency is determined by the source of the wave, not by the medium. So frequency is directly related to the source of the wave, correct? Not with the medium. So if you're changing the medium, it will not affect the frequency, correct? Wavelength varies with medium. Means this wavelength is directly, you can say, depends on the medium. How the medium is. It's air, it's you can say gas, solid, liquid, which kind of medium it is. So wavelength depends on medium. Frequency not depends on medium. Okay, so medium means air, water, or like solid. These any kind of medium you can take. So when the wave travels from one medium to another, its wavelength changes depending on the speed of the wave in the new medium. Now speed, it also depends on medium. So wave speed depends on the properties of the medium, such as density, its elastic property. So for example, if the wave travels faster in solids than in liquid and faster in liquid than in gases, because particles are closest together in solids. So generally, if you do the experiment, like take the table, okay, in that table, ask your friend to put the ear this side, okay, and you just put something here with the pen or something, strike on it, and then ask your friend that how she heard. So it will be louder for her, because the wave travel fast, means this is speed, wave travel faster in the solid, okay, as compared to the air, as compared to the liquid. Is it clear?